Welcome to the peaceful space of sleep-friendly science, where the gentle hum of the cosmos is our lullaby as we journey to witness a star's final, magnificent farewell. Allow your mind to drift far beyond our world, to the cosmic theater where stars are born and fade. Tonight, we gently focus on one of these final moments, a massive star's spectacular collapse. What happens in that instant? It becomes a black hole, a place of infinite density and mystery. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Ancient Giant Awakens. Let the world around you soften and fade. Allow the gentle darkness behind your closed eyes to become a different kind of darkness, not one of absence, but of infinite possibility. It is the velvet expanse of deep space, cool and silent, waiting for us to explore. With each slow breath, you feel yourself drifting, becoming lighter, leaving the weight of the day behind. We are not traveling with speed, but with intention, moving across the cosmos as if in a dream. Our destination is far from the familiar shores of our own solar system. We cross gulfs of time and distance, past the ghostly, gossamer veils of nebulae where new stars are being born, and through the silent graveyards of other, long-dead suns whose light has turned to memory. You are a silent, weightless observer, a traveler of the mind, drawn toward a single, brilliant point of light that grows steadily against the black canvas. It is a star, but not just any star. This is a celestial titan, a supergiant, a luminous monarch that has reigned over its patch of the galaxy for millions upon millions of years. As we draw closer, you can perceive its color, not the warm yellow of our own sun, but a fierce, brilliant, almost electric blue. It is the color of immense heat, of unimaginable power, a blazing ultramarine fire that has burned with a steady, magnificent rage since a time before our own world knew life. From this safe distance, you can feel its presence not as heat, but as a kind of ancient, resonant hum. It is the sound of existence on a scale we can barely comprehend. This star is a city of light, thousands of times brighter than our sun. Its surface a roiling, tempestuous ocean of plasma. Great arcs of energy, larger than entire planets, leap from its surface in a slow, graceful ballet before being pulled back by a force we cannot see. For eons, this giant has been a monument to stability, a perfect, self-sustaining creation. It is a cosmic lighthouse, having witnessed the slow, graceful waltz of distant galaxies, the silent passage of rogue planets, and the birth and death of countless smaller, less dramatic stellar siblings. It has held its form and its fire in a state of exquisite, delicate balance. This balance is the secret to its long life, the very soul of its being. It is a divine stalemate between two colossal, opposing forces. The first force is one you know intimately, though you may not think of it this way. It is gravity, the same force that holds you gently to your bed, that pulls the rain to the earth, that keeps our moon in its faithful orbit. But here, in a star of this impossible mass, gravity is a monster. It is a relentless, crushing inward pressure. Every single particle of this star, every atom of hydrogen, every ion of helium is being pulled with unimaginable force toward the very center. Imagine the weight of 1,000 suns, all trying to collapse into a single point. Gravity is an unseen hand, constantly, tirelessly, trying to squeeze this star into oblivion. It is a quiet promise of collapse, whispered from the core outwards. And yet, the star does not collapse. It shines. It burns. Pushes back. This is the second force, the star's brilliant, defiant answer to gravity's patient siege. Deep within the core, in a crucible of pressure and temperature so extreme that our minds can barely sketch an outline of it, a miracle is happening. This is the miracle of nuclear fusion. Here, in the star's heart, atoms are not merely crowded together. They are violently forged into new, heavier forms. The star has spent the vast majority of its life taking the simplest element, hydrogen, and crushing its nuclei together to create helium. This act of creation, this atomic alchemy, unleashes a torrent of energy. It is an outward explosion, a continuous, controlled detonation that has lasted for an age. This is the star's radiance. This is its light, its heat, its life. It is a thermonuclear furnace generating a constant, powerful breath that pushes against gravity's inward squeeze. So you see the dance. Gravity pulls in. Fusion pushes out. For millions of years, these two forces have been perfectly matched. Gravity's crushing hand is met by the radiant fist of fusion. The inward fall is halted by the outward blast. It is a cosmic breath, held for an eon. The star's very structure, its spherical shape, its stable size, is a testament to this perfect equilibrium. It exists on a knife's edge, a moment of peace between two infinityist infinity of collapse and the infinity of explosion. From our vantage point, you watch this ancient giant, suspended in the quiet of space, and you can almost feel that tension. You can sense the colossal forces at play, the war being waged in its heart that results in the beautiful, serene light bathing us now. This star is not just a ball of hot gas. It is a living, breathing entity, its life defined by this fundamental conflict. Its blue-white brilliance is the flag of a temporary victory, a declaration that for now, life and light are winning against the inevitable, patient pull of the dark. For now, the equilibrium holds. The ancient giant breathes, unaware that the very fuel that sustains its glorious defiance is beginning to run low. The rhythm of its heart is about to change. Section 2. The faltering heartbeat. We continue our silent vigil, floating in the velvet dark, our gaze fixed upon the luminous, blue-white giant. For now, all seems as it has for ages. The star hangs in space with a look of serene permanence, a diamond on black cloth. The perfect balance between gravity's inward crush and fusion's outward fire holds it in a state of grace. But the story of a star, like all stories, is one of change. And the first change is not a dramatic flare or a sudden dimming, but a whisper, a subtle shift so deep within its core that, from the outside, nothing yet seems amiss. Let your awareness drift inward, past the roiling, bright surface, through layers of incandescent gas hotter than any earthly fire. We are journeying to the star's heart, the very engine room where its life is forged. For millions of years, this core has been a kingdom of hydrogen, an endless supply, it seemed, of the universe's simplest element, offered up to the furnace. But no supply is truly endless. After eons of continuous, ravenous burning, the hydrogen in the very center is nearly gone. The primary fuel, the star's first and longest-lasting meal, has been consumed. What remains is the byproduct, the ash of this first fire, a dense, growing sphere of helium. Imagine a campfire that has burned all night. As the wood turns to embers and ash, the flames shrink, the heat lessens, and the circle of warmth and light contracts. In the heart of our star, a similar event is unfolding on a cosmic scale. The hydrogen fusion begins to sputter. The thermonuclear reactions that produce the star's outward, life-sustaining pressure become less frequent, less powerful. The great outward breath of fusion, which has held gravity at bay for so long, begins to quieten. And in that quiet, gravity, the patient, ever-present force, senses its opportunity. It has been waiting for this moment of weakness since the star was born. With the outward push diminished, gravity's relentless inward pull is no longer perfectly balanced. It begins to win. The core of the star, no longer supported by the full force of fusion, begins to contract. A slow, inexorable squeeze begins. The helium ash, the remnant of the first fire, is being crushed under the star's own impossible weight. It is a silent, internal catastrophe, a faltering heartbeat. The star's equilibrium is broken. Yet, this moment of collapse is not the end. It is, paradoxically, the catalyst for a new, more furious kind of life. As the core contracts, the pressure and temperature within it skyrocket to levels it has never before experienced. The squeeze becomes so intense, the heat so unimaginable, that it reaches a new, critical threshold. It becomes hot enough to ignite the very ash of the previous fire. The helium, which was once the inert byproduct, now becomes the fuel. A new fire is lit in the heart of the star, the fire of helium fusion. This is not the same gentle, steady burn of hydrogen. Helium fusion is a more violent, more potent process. It forges the helium atoms into even heavier elements, primarily carbon and oxygen. The star has learned a new trick, a new form of alchemy, born out of a moment of desperation. And this new fire burns with a ferocity that dwarfs the star's previous life. The faltering heartbeat does not stop. It returns as a thunderous, hammering pulse, stronger and more powerful than before. The outward pressure from this new furnace is immense, far greater than what the star knew in its youth. This colossal new surge of energy pushes outward from the core with renewed vigor, and the star must accommodate it. The star's outer layers, the vast envelope of gas that makes up its visible body, begin to swell. Like a great lung taking a slow-motion breath over thousands of years, the star expands. It grows larger and larger and larger still, swelling to hundreds of times its original diameter. It is transforming, becoming a true giant of the cosmos. There is a beautiful paradox in this transformation. While the core burns hotter than ever before, the star's surface, now stretched out over a much greater area, begins to cool. Its energy is spread thin, and as it cools, its color begins to change. The fierce, brilliant blue-white of its youth softens. It shifts like hot metal cooling down the spectrum through white to yellow to a deep and final orange, and then to a smoldering, majestic red. Before our eyes, the star has aged. It has become a red supergiant. Its once compact, searing brilliance has been traded for a vast, luminous, and more temperate grandeur. If it were to replace our own sun, its new, bloated surface would extend past the orbit of Earth, perhaps even to Mars or Jupiter. It is no longer a star. It is a world-swallowing celestial entity. This new state feels stable, but it is a fragile, temporary piece. The star's life is no longer a single, long-held note. It has become a frantic symphony of cycles. It will burn through its helium for a shorter time than it burned its hydrogen. And when the helium is gone, the heart will falter again. Gravity will squeeze again. The pressure and temperature will rise again. And a new, even heavier element will be forced to burn. You are witnessing the star's old age, a turbulent, dramatic period of constant change. It is now living on borrowed time, burning through its heavier fuels at an ever-accelerating rate. Each new stage of burning is shorter and more violent than the last. Carbon will burn to create neon and magnesium. Neon will burn to create silicon. It is a desperate, cascading series of reactions, a race against the inevitable triumph of gravity. With each new fire it lights in its core, it climbs another rung up the periodic table, forging the very stuff of planets and of life. But it is also taking another step closer to its final, unavoidable collapse. The faltering heartbeat will one day have no answer. The fire will have nothing left to burn. Section 3. The Unburnable Ash. We remain with our red supergiant, a vast, smoldering globe of light that now dominates this region of space. The sheer size is difficult to comprehend. It is a slow-motion storm, its surface a turbulent sea of cooling gas, its heart a frantic, layered furnace. It has found a new, albeit temporary, equilibrium. But beneath the surface, a desperate race against time is unfolding. The star is aging in dog years, living 1,000 lifetimes in the span of a cosmic moment. Let us journey once more into its core. The experience is different now. The heart of the star is no longer a single, uniform furnace. It is structured like an onion, a series of concentric, nested shells, each one a relic of a previous era of fusion. In the outermost layers of the core, hydrogen is still burning into helium. Deeper in a hotter, denser shell, helium is being forged into carbon and oxygen. Deeper still, where the pressure is even more immense, carbon is fusing into heavier elements. And so it goes, a cascade of creation, each layer burning a heavier fuel, each layer hotter and denser than the one before. Each of these burning stages represents a brief reprieve, a temporary pushback against the relentless inward crush of gravity. The hydrogen burning phase lasted for millions of years. The helium burning phase that followed lasted for perhaps a few 100,000. The carbon burning stage might last only a few centuries. The subsequent stages neon, oxygen, silicon are even more fleeting. The star is burning through its life story at a terrifying pace. The silicon burning phase, the last great act of defiance, will last for perhaps a single day. One day, after millions of years of steady light, the star's final fuel will be consumed in less time than it takes our own planet to complete a single rotation. Imagine the intensity of that final, furious burn. The star is throwing everything it has left onto the fire, trying to hold back the inevitable. And now we travel to the very center, the final layer of this cosmic onion. We arrive at the last product of this frantic, cascading chain of fusion. Here, in the star's innermost sanctum, the silicon has burned, and it has created something new, something final. The core is now a rapidly growing sphere of pure iron. This is the end of the line, and it is the star's death sentence. Why iron? Why is this element the final, fatal barrier? Because of a fundamental rule of nuclear physics, a law as old as the universe itself. Up until this point, every act of fusion has been a net gain for the star. Fusing lighter elements into heavier ones, hydrogen into helium, helium into carbon, has always released energy. This released energy is what created the outward pressure, the radiant breath that held gravity at bay. It was a profitable transaction for the star. It spent a little mass and got a lot of energy in return. But iron is different. Iron sits at a perfect point of nuclear stability. It is the most tightly bound nucleus in existence. To fuse iron atoms into something heavier requires energy. It doesn't release it, consumes it. It is an energy debt. For the star, trying to burn iron is like trying to light a fire with wet sand. It is an impossible, energy-losing proposition. The star, which has lived its entire life by the grace of fusion, has finally created a substance it cannot burn. The iron core is not fuel. It is ash, the ultimate unburnable ash. And so, the fire at the very center of the star goes out. Not with a sputter, but with a sudden, definitive halt. The silicon burning shell surrounding the core deposits its last flecks of iron ash onto the central sphere, and then it too falls silent. The innermost engine cuts out. The final, deepest layer of the onion stops pushing back. For a breathtaking moment, a fraction of a second, the star exists in a state of profound and terrifying silence. The outward pressure from the core, the force that has defined its entire existence, is gone. It has vanished. There is now nothing, absolutely nothing at the star's center to oppose the force of gravity. Gravity, the patient victor, has been waiting for this moment for millions of years. It has been squeezing, testing, and waiting, and now its adversary has fallen. There is no more resistance. The stalemate is over. The iron core itself is already incredibly dense, a sphere perhaps the size of our Earth, but containing the mass of more than 1.5 suns. It is a ball of matter pushed to the very brink of what is possible. And in the instant that the fusion stops, that brink is crossed. The core, no longer supported from within, becomes aware of the crushing weight of the entire star resting upon trillions of tons of gas, all pulling inward, all at once. The structural integrity that held the core together simply vanishes. The forces binding its atoms are no match for the gravity of a supergiant star. A process that has taken millions of years to unfold now reaches its climax in an instant. The story of the star's life is over. The story of its death is about to begin. And it will be faster, more violent, and more transformative than anything that has come before. The iron heart, the unburnable ash, begins to fall inward upon itself. The final collapse has begun. Section 4. The moment of implosion. The silence in the star's heart is a deafening one. It is the silence of a held breath, the pause before the thunderclap. The iron core, that inert sphere the size of a planet, is now utterly at the mercy of gravity. And gravity does not hesitate. What happens next is not a slow settling, not a gentle squeeze. It is a cataclysm of such speed and violence that it redefines our understanding of the word fast. It is an implosion. The core begins to collapse. Imagine dropping a stone into a pond. Now, imagine that the stone is the size of the Earth, and the pond is the fabric of reality itself. The core is falling inward on itself from all directions at once. The outer edge of the iron sphere, which is thousands of miles across, begins to plummet toward the center. It accelerates with a ferocity that is difficult to picture. Within a fraction of a second, it reaches a significant fraction of the speed of light, perhaps a quarter or even a third. It is moving at tens of thousands of miles per second. This is not like a building collapsing under its own weight. A building falls through air. The star's core is falling through itself. It is a cascade of matter, a spherical avalanche moving at relativistic speeds toward a single point. The layers of the star that surround the core, the shells of silicon, oxygen, carbon, and helium, are momentarily left behind. They are still held in place by their own inertia, hanging in space for a split second, unaware that the floor beneath them has just vanished. Let us follow the collapsing matter inward. As the iron core plummets, it is crushed with a force that defies analogy. The very structure of matter, the rules that govern the atoms themselves, begin to break down. First, the electron shells, the delicate orbital clouds that give atoms their volume, are shattered. The electrons are stripped away from their atomic nuclei, creating a superdense soup of bare iron nuclei and a sea of free-roaming electrons. The core has become something beyond solid, liquid, or gas. It is a state of matter known as electron-degenerate plasma. But the collapse does not stop there. Gravity is not satisfied. The core continues to shrink, the pressure and density climbing to numbers that are almost meaningless to the human mind. The pressure becomes so immense that it overcomes one of the fundamental forces of nature, the force that keeps electrons separate. A quantum mechanical rule says that two electrons cannot occupy the same state in the same space. It is this rule, this electron degeneracy pressure, that has been helping to hold the core up. But now, gravity is so strong that it breaks this rule. The electrons, with nowhere left to go, are physically forced into the protons of the iron nuclei. An electron and a proton, when crushed together, neutralize each other and become a single new particle, a neutron. This process is called inverse beta decay, and it happens all at once throughout the entire collapsing core. It is a moment of profound and violent alchemy. The core of the star, in an instant, ceases to be made of iron. It is transformed into a sphere of pure, tightly packed neutrons. Every proton has captured an electron, converting the entire substance of the core into a new, bizarre state of matter. We have just witnessed the creation of a neutron star, or at least the protoneutron star that will form the heart of the resulting object. This transformation has two immediate, dramatic consequences. First, in that flash of conversion, a colossal burst of tiny, almost massless particles called neutrinos is released. These neutrinos barely interact with normal matter. They can pass through an entire planet as if it were empty space. But so many are created in this instant, in this single act of transmutation, that they carry away an immense amount of energy. It is a silent, invisible blast that erupts from the core. Second, the collapse, which has been proceeding almost unchecked, suddenly hits a wall. A new kind of pressure arises, neutron degeneracy pressure. Like the electrons before them, neutrons also resist being squeezed into the same space. But this resistance is far, far stronger. The collapsing matter, moving at nearly a third of the speed of light, smashes into this incompressible wall of neutronium. The result is a shockwave, a cosmic rebound of unimaginable power. Imagine throwing a hypervelocity rubber ball against a steel wall. The ball doesn't just stop. It bounces back with ferocious energy. This is what happens to the core. The inner part of the core, having transformed into neutronium, becomes incompressible. The outer part of the core, which is still raining down upon it at incredible speeds, slams into this newly formed rigid surface. The infall is violently arrested. The inward falling matter crashes, compresses, and then recoils in a titanic shockwave that begins to propagate outward. The implosion turns into an explosion. The fall becomes a bounce. The death of the star's heart becomes the trigger for its most glorious and spectacular display. All of this, the collapse of the iron core, the smashing of atoms, the transformation into neutrons, the neutrino burst, and the formation of the rebound shockwave, all of it happens in less than 1 second. The lifetime of a star, measured in millions of years, culminates in a final, defining moment that is over before you could even draw a breath. The stage is now set. The shockwave is racing outward, about to meet the unsuspecting outer layers of the star, which have only just begun their own slow descent into the void left by the collapsed core. A great secret is about to be told to the rest of the star and to the universe beyond. Section 5. A universe in bloom. The shockwave, born from the violent rebound of the star's core, is not a wave of sound or light. It is a wave of pure, kinetic force, a moving wall of pressure and heat, now blasting outwards from the newly formed neutron star heart. It begins its journey back through the star, a journey that is the mirror image of the collapse that just occurred. It races outwards, determined to deliver the news of the core's demise to the star's unsuspecting outer layers. These layers, the vast, bloated envelope of the red supergiant, they've only just started to react to the sudden loss of support from below. They have begun to fall inward, a slow, heavy, cosmic rain. The shockwave meets this descending rain of matter head-on. Titanic struggle ensues. For a moment, it seems the shockwave might fail. It plows into the dense, infalling layers of silicon and oxygen, losing energy with every particle it hits. It is like a swimmer trying to fight their way upstream against a powerful current. The sheer mass of the overlying star is immense, and it presses down, threatening to smother the shockwave, to stall it and crush it before it can ever reach the surface. In some cases, in some stars, this is exactly what happens. The shockwave dies, and the star collapses directly into a black hole with barely a whisper. But for our star, something else is happening. Remember that invisible, silent blast of neutrinos that erupted from the core a moment before? Those trillions upon trillions of ethereal particles are also streaming outwards. While they barely interact with matter, the density inside the star is now so great that a small fraction of them, perhaps just 1%, do not escape cleanly. They slam into the plasma just behind the stalling shockwave. Imagine a sail that is starting to flag, and suddenly it is hit by a powerful, invisible gust of wind. This is the effect of the neutrinos. They deposit a colossal amount of energy into the material behind the shockwave, reheating it, re-energizing it, and giving it the extra push it needs to overcome the infalling matter. The stalled shockwave is resurrected. It becomes an unstoppable force. Now, with renewed vigor, it annihilates everything in its path. It tears through the remaining shells of the star's onion-like core, a wave of pure obliteration. As it travels, it becomes a furnace in its own right. The heat and pressure are so extreme that they trigger a final, explosive burst of nuclear fusion, a process called explosive nucleosynthesis. Elements heavier than iron, elements that a star could never create in its lifetime, gold, platinum, silver, uranium, are forged in this fleeting, violent passage. The very atoms that make up our most precious metals are born in this instant, in the heart of a dying star's death rattle. The shockwave finally reaches the vast, tenuous outer layers of hydrogen and helium. It hits them like a hammer striking a bell. The energy is transferred, and the star's entire massive envelope, trillions of tons of gas, is instantly superheated to millions of degrees and blasted outwards into space. This is the moment of breakout, the moment the star finally, truly explodes. From our safe vantage point, we see it happen. A point of light on the star's surface begins to shine with an impossible, searing brilliance. In a matter of hours, the star's brightness increases a billionfold. It becomes brighter than its entire host galaxy. A single, dying star now outshines hundreds of billions of living ones. If this were happening in our own Milky Way, it would be visible in broad daylight on Earth, a new and terrifyingly bright star in the sky. This is a supernova. The outer layers of the star, once part of a cohesive whole, are now a rapidly expanding cloud of debris, racing away from the center at 1/10 of the speed of light. It is a celestial ghost, an expanding, glowing shell of gas and newly forged elements. It is the star's final, magnificent gift to the cosmos. For millions of years, the star hoarded these elements within itself. Now, in its death, it scatters them across interstellar space like a farmer sowing seeds. The carbon, the oxygen, the neon, the iron, and now the gold and platinum, all the building blocks of future worlds and future life, are flung far and wide. This expanding cloud, this supernova remnant, will travel for thousands of years, mixing with the cold, thin gas between the stars, enriching it, seeding it with the potential for new creation. One day, far in the future, a different cloud of gas and dust, seeded by the ghost of our star, will begin to collapse under its own gravity. It will form a new star, and perhaps around that new star, a series of smaller celestial bodies will form. Planets. And on one of those planets, the oxygen might form an atmosphere, the carbon might form the basis of organic molecules, and the iron might form a molten core generating a magnetic field. The very substance of life, of worlds, of us, is forged and distributed in these spectacular, violent moments of stellar death. We are, in a very real sense, made of stardust. Not just from any star, but from the explosive death of giants like the one we are witnessing now. The supernova blooms, a silent, cosmic flower of impossible beauty and scale. It will glow for weeks, for months, before slowly, gracefully, fading from view, its light scattered, its matter dispersed. But our story is not over. Because while the star's outer layers have been given a glorious farewell, something remains at the heart of the explosion. The core, the dense, crushed remnant that started it all. For it, the journey is just beginning. Section 6. The crushing of matter. The glorious, expanding nebula of the supernova is a spectacle for the universe to see, a final, luminous wave goodbye. But our journey now takes us back to the epicenter, to the source of that cataclysmic explosion. We drift through the fiery, outward-rushing veil of gas, back toward the point of origin. Here, at the heart of the fading celestial flower, lies the remnant, the core, the dense, compact object left behind after the star's outer layers were blasted away. In a less massive star, this object would be the end of the story. It would be the neutron star we witnessed being born, a sphere perhaps only a dozen miles across, yet containing more mass than our sun. A city-sized celestial body so dense that a single teaspoon of its substance would weigh billions of tons. It would be a phenomenal, exotic object, a pulsar perhaps, spinning rapidly and flashing beams of light like a cosmic lighthouse. It would cool and exist for eons, a quiet gravestone marking the star's final resting place. But our star was not just any star. It was a titan. It was exceptionally massive, perhaps 30 or 40 times the mass of our sun, or even more. And because of its immense starting mass, the remnant core it left behind is also exceptionally massive. The supernova explosion, as powerful as it was not powerful enough to blow away the entire star. A significant amount of matter, after the initial rebound, did not achieve escape velocity. It is now raining back down. Imagine the scene. The outward shockwave has passed, but a torrent of matter, unable to escape the core's immense gravity, reverses course and begins to fall back onto the newly formed neutron star. It is a rain of superdense, superheated plasma, adding more and more mass to the tiny, compact object at the center. The neutron star grows heavier. It started with a mass of maybe 1.5 times that of our sun. Now it swells. 1.6 solar masses. 1.8. It reaches 2 solar masses. The neutron degeneracy pressure, that incredibly powerful force that halted the initial collapse, is still pushing back. It is the last fundamental force standing in the way of ultimate collapse. But like all things, it has a limit. This limit is called the Tolman-Oppenheimer-Fokoff limit. It is a theoretical maximum mass that a non-rotating neutron star can have before it can no longer support itself. This limit is not known with perfect precision, as it depends on the exotic physics of neutronium, but it is thought to be somewhere between 2 and 3 solar masses. The rain of matter continues. The core swells past 2.5 solar masses, then 2.8, and then it crosses the threshold. The neutron degeneracy pressure fails. The last line of defense is broken. The final force that was holding matter apart gives way. And now there is nothing left. No known force in the universe can halt what is about to happen. Gravity, which was briefly thwarted by the neutron rebound, now reasserts its absolute, final, and uncontested dominion. The core, which was already an object of unimaginable density, begins to collapse again. This is the second collapse, the final collapse, and this time there will be no rebound. There is nothing to bounce off of. There is no new state of matter to be born. There is only falling. The entire mass of the core 3 suns worth of matter, once a sphere a dozen miles across, resumes its inward plunge towards the center. The very idea of surface dissolves. The neutrons themselves are crushed. What happens to them? Our physics, our understanding of reality begins to break down here. Are they squeezed into their constituent quarks, creating a quark star? Perhaps, for a fleeting instant. But even the forces that bind quarks together are no match for this ultimate gravitational vice. The matter is not just being compressed. It is being erased from existence as we know it. It is being crushed into a point of zero volume. All the mass, all the history, all the complexity of three suns is being squeezed into a region smaller than the nucleus of an atom. It is falling toward a state of infinite density. This is a concept that our minds are not equipped to handle. Infinity is a mathematical idea, not a physical one. When it appears in the equations of physics, it is a sign that the theory itself has broken down, that we have reached the edge of our knowledge. We have reached a place where the rules of general relativity and the rules of quantum mechanics, the two great pillars of modern physics, give conflicting reports. We have reached a place for which we have no map. We call this destination the singularity. As an outside observer, you cannot see this happening. The process is shrouded, hidden from the universe. As the core collapses past a certain point, the gravitational pull in its immediate vicinity becomes so extreme that it begins to warp the very fabric of space-time around it. Imagine space as a stretched rubber sheet. A planet or a star creates a small dimple in that sheet. Our collapsing core, however, is not creating a dimple. It is punching a hole clean through it. The escape velocity from the surface of the collapsing object is increasing with every passing microsecond. It quickly surpasses the speed of any spaceship. Then it surpasses the speed of light itself. This is the critical moment, the moment a black hole is truly born. A boundary forms around the collapsing point, a one-way membrane, an invisible sphere in space. It is a threshold of no return. Anything that crosses this boundary matter, energy, even light itself can never, ever get back out. It is captured, inevitably pulled down into the singularity at the center. This boundary is the event horizon, and it is the only part of the black hole we can ever hope to witness. The final, violent crushing of matter into the singularity happens inside this horizon, forever shielded from our view. The universe has drawn a curtain around its most extreme and mysterious creation. The star, which began as a brilliant beacon of light, has ended its life by creating a region of perfect, absolute darkness. Section 7. Weaving the cloak of spacetime. The final collapse is underway. The remnant of the star's core is plummeting towards that unknowable point of infinite density. But as we watch from our safe, silent vantage point, we do not see the matter vanish. We do not see a singularity form. The universe, in its strange and subtle way, protects its own secrets. Instead, we witness something even more profound, the birth of a new kind of geography, a boundary made not of matter, but of consequence. We witness the weaving of the event horizon. Think of spacetime as a flowing river. Throughout most of the universe, this river is calm and slow-moving. Objects can travel freely within it, moving upstream or downstream as they please. A beam of light is the fastest swimmer in this river, able to travel against any normal current. But what is happening here around our collapsing star core is that the river of spacetime itself is starting to flow inwards, pulled by the immense gravity. As the core shrinks, this inward flow accelerates. Closer and closer to the collapsing mass, the current of spacetime gets stronger and stronger. Imagine a boat trying to move away from a colossal waterfall. First, it's easy. Further in, it needs more power. And then, there is a point, a line in the water, where the river itself is flowing towards the falls faster than the boat's maximum speed. No matter how hard the engine works, the boat is carried backwards over the edge. The event horizon is precisely this line for light. It is the exact distance from the central point where the flow of spacetime inward the gravitational current is equal to the speed of light. Inside this boundary, spacetime itself is falling into the singularity faster than light can travel. Since nothing can travel faster than light, nothing inside the event horizon can escape. The fastest swimmer in the cosmic river is now being swept over the falls. It is the ultimate point of no return. This boundary is not a physical surface. You would not feel it if you passed through it. There is no wall, no membrane of fire or energy. It is a purely geometric and causal boundary. It is a threshold in space-time. Before you cross it, you have a future that could include leaving. After you cross it, all of your possible future paths, every single trajectory you could ever take, end at the singularity. Space itself has been so warped that the only direction left to travel is down. From our perspective, outside this forming boundary, something strange and wonderful happens, as described by Einstein's theory of general relativity. Let's imagine a single brave photon of light emitted from the surface of the collapsing star just as the event horizon is about to form over it. This photon is trying to escape, to fly away and carry the last image of the star's surface out into the universe. But it is fighting against an increasingly powerful gravitational pull. This pull stretches the photon's wavelength, stealing its energy. This is called gravitational redshift. A blue photon full of energy would be stretched to become a red photon with less energy. As the collapse continues, a photon trying to escape from even closer to the forming horizon would be stretched even Moretto infrared, to microwave, to a radio wave with almost no energy at all. And for us, the outside observers, something even stranger happens to time. Gravity warps not just space, but time as well. The stronger the gravity, the slower time passes relative to an observer far away. This is called gravitational time dilation. So, as we watch the star collapse, time on its surface appears to slow down. The final moments of the collapse seem to take longer and longer. The light from that last escaping photon is not only redshifted to oblivion. Its journey is time-dilated towards infinity. From our point of view, the surface of the star appears to slow its collapse, to dim and to freeze. The final image of the star seems to be painted onto this invisible boundary, this event horizon, for all eternity. We would never actually see the star disappear. We would only see it become dimmer, redder, and slower, frozen forever at the edge of oblivion. A faint, ghostly afterimage, stretched across an eternity we could never live long enough to witness. The event horizon forms with a size directly proportional to the mass it contains. For a black hole with the mass of 3 of our suns, this spherical boundary would be about 9 kilometers in radius, a tiny, invisible sphere, perhaps 18 kilometers or about 11 miles across. Into this tiny volume, a star has vanished, and so the cloak is woven. Space-time itself has created an impenetrable shroud around the star's final violent act. The supernova has faded, its light now traveling across the galaxy as a mere memory. The crushing of matter into the singularity is happening, but it is hidden, locked away behind a one-way door. What is left is the black hole itself, a region of space-time, not a physical object in the traditional sense. It has no surface, no color, no texture. It is defined only by its most fundamental properties: its mass, its spin, for it will likely be rotating, and its electric charge, which is usually negligible. All the other details of the star that formed it was made of iron, that it was once a brilliant blue Goliathol, that information has been lost, or at least hidden behind the horizon. This is poetically known as the no-hair theorem, that black holes are remarkably simple, featureless objects. The star is gone. In its place is a silent, perfect sphere of darkness, a wound in the fabric of reality, a gravitational ghost, whose only influence on the universe outside is its immense, inescapable pull. It waits, patiently, a silent monument to the power of gravity. Section 8. Journey past the point of no return. We have watched the star die. We have seen its final, brilliant supernova bloom and fade. We have witnessed the weaving of the event horizon, that perfect sphere of darkness that now hangs in space, a silent testament to gravity's ultimate victory. From the outside, the story seems to be over. The black hole is a static, featureless object, a simple gravitational anchor. But our journey, a journey of thought and imagination guided by the strange predictions of physics, does not have to end at the edge. Let us be brave. Let us, in our mind's eye, become a theoretical observer, a single point of consciousness continuing the fall. We cross the event horizon. The moment of passage is utterly unremarkable. As predicted, there is no wall, no bell, no change in the local laws of physics. The space around you looks and feels the same as it did a moment before. If you were in a spaceship, your instruments would detect no sudden jolt or change in pressure. The darkness ahead might look a little darker, but that is all. The light from distant stars and galaxies, falling into the black hole behind you, becomes distorted and blue-shifted. The entire history of the cosmos, from the Big Bang to its eventual end, would flash before your eyes in a concentrated warp display. But you cannot turn back to it. The exit is gone. All paths now lead forward, inward. The nature of space and time has fundamentally switched roles. Outside the black hole, you have freedom of movement in the 3 dimensions of space: forward/backward, left/right, up/down, but you are forced to move relentlessly forward in the single dimension of time. Inside the event horizon, this is reversed. The dimension of space leading to the singularity becomes your future. You are now forced to move down toward the center, just as you were once forced to move forward into your future. There is no more freedom of movement in this direction than you have in preventing next Tuesday from arriving. It is your destiny. In contrast, you now have a strange, limited freedom in the time dimension. You could, in theory, see all of history for the small patch of spacetime you occupy, but you cannot escape your spatial fate. The river of spacetime is now a torrent, and it is carrying you to the falls. As you fall deeper, the force of gravity becomes exponentially stronger. And it is not a uniform force. This is the most terrifying and destructive aspect of the journey. The gravitational pull on the part of you closer to the singularity is vastly stronger than the pull on the part of you farther away. This differential is known as a tidal force. Imagine you are falling feet first. Your feet are being pulled with so much more force than your head that you are being stretched. First, it is a gentle tug. Then it becomes an irresistible pull. Your body is elongated, pulled like taffy. This process is poetically and horrifically known as spaghettification. Any object, whether a spaceship, a planet, or a person, would be torn apart by these tidal forces long before reaching the center. You would be stretched into a thin stream of atoms, a trail of matter spiraling down into the abyss. The very structures that hold you together are undone by the steep gradient of spacetime itself. The view also becomes profoundly bizarre. The singularity is not a point of light ahead of you. It is not a place you see in the traditional sense. Because all paths lead to it, the singularity effectively lies in your future. So, no matter which way you look, left, right, up, down, you are looking at the singularity. Surrounds you. It is an all-encompassing, inevitable destination. The darkness is absolute, as light itself is being pulled alongside you, unable to illuminate anything. You are a stream of fundamental particles now, stripped of all form and structure, your consciousness a theoretical construct for this thought experiment. The warping of spacetime becomes extreme. Space twists and contorts in ways that we have no language to describe. You are in the realm where general relativity predicts its own failure, a place of infinities where our science becomes a kind of poetry, sketching out ideas that it cannot prove. This journey from the event horizon to the center is surprisingly quick. For a black hole of this Sisyphus few solar masses, the trip from the edge to the inevitable crush at the center would take only a few microseconds. It is a one-way, short, and final ride. a final, brief fall into the heart of a broken piece of the universe. We are approaching the end of the line, the place where the journey must end, because space and time as we understand them cease to exist. We are approaching the heart of the mystery, the place all the matter of the star's core now resides, crushed into a state that has no volume and no dimensions. We are approaching the singularity. Section 9. The Heart of Infinity. Our theoretical journey, our stream of spaghettified atoms, is now in its final moments. The tidal forces have become infinite. The curvature of spacetime has become infinite. We have arrived at the destination that has been inevitable since we crossed the event horizon. We have arrived at the singularity. What is this place? The honest scientific answer is, we do not know. The word singularity is, in many ways, a term of surrender. It is a name we give to a place where our most successful theory of gravity, Einstein's general relativity, breaks down. The equations that describe the universe so beautifully, that predict the bending of starlight and the orbits of planets with stunning accuracy, suddenly produce nonsensical answers when applied to this point. They produce infinities. Infinite density, infinite spacetime curvature, infinite pressure. In physics, an infinity is not an answer. It is a signpost that points to a missing piece of the puzzle. It tells us that our theory is incomplete. General relativity is a classical theory. It describes a smooth, flowing spacetime. But at the scales we are now considering the subatomic realm where all the mass of a star core is concentrated, we need a theory that incorporates the strange and pixelated world of quantum mechanics. We need a quantum theory of gravity, and we do not have one. So, when we try to describe the singularity, we are standing at the absolute frontier of human knowledge, peering into an abyss of our own ignorance. We can only speculate, guided by theory and by imagination. Let us consider what a singularity is not. It is likely not a literal, infinitely small geometric point. That is a mathematical idealization. Many physicists believe that a future theory of quantum gravity will smooth out this infinity, replacing the point with something else, something even stranger but physically more plausible. One idea is that it could be a quantum foam or a spacetime foam. At this tiniest of scales, spacetime itself might not be smooth, but a roiling, chaotic sea of tiny, Planck-length fluctuations, where wormholes and tiny universes bubble in and out of existence for fleeting instants. The matter of the star would be crushed into this foam, its information smeared across this bizarre, energetic substrate. Another, more speculative idea is that the singularity is not an end, but a bridge. Some theories propose that the matter falling into a black hole could rebound on a quantum level and emerge somewhere else, perhaps in another universe. Or perhaps it could trigger a new Big Bang, creating a daughter universe. In this beautiful cosmic view, black holes are not just graves for stars, but wombs for new cosmoses. Our own universe, in fact, might have been born from a singularity inside a black hole in a previous parent universe. This is a profound and untestable idea, but it speaks to a deep human need for cycles, for creation to emerge from destruction. Or perhaps the truth is something we cannot yet even conceive. Perhaps matter, when crushed to this extent, transforms into a form of pure information, plastered onto the event horizon in a holographic way, as some interpretations of string theory suggest. In this view, the three-dimensional reality we witnessed falling into the black hole is encoded on its two-dimensional surface, the event horizon. What we do know is that the singularity represents the ultimate victory of gravity. It is a place where matter has been so thoroughly defeated that it has been stripped of its very properties, of its extension in space. All the complexity of the star, its layers of fusion, its history spanning millions of years, the unique combination of elements it forged, has been reduced to a single point of mass. It is the ultimate compression of a story into a single unreadable word. As our imaginary journey ends here, crushed out of existence, we can reflect on this profound mystery. The star began as a vast, radiant, complex entity. It lived a dramatic life of fusion and transformation. It died in a blaze of glory that seeded the universe with the stuff of life. And its heart, the very engine of its existence, has become a question mark at the center of a hole in reality. It is a place where time and space end, where cause and effect may lose their meaning. It is the final repository of everything that falls into the black hole, a silent, timeless vault. We stand at the edge of this concept, humbled by the scale of what the universe can create, and by the vastness of what we have yet to understand. The singularity is not just the heart of the black hole. It is the heart of a fundamental cosmic enigma. It is the point where the universe asks us a question to which we have not yet found the words to reply. Section 10. The Silent, Waiting Ghost. Let us pull our awareness back now. We retreat from that impossible center, from the unknowable heart of the singularity where our physics and our imagination must fall silent. We pull back through the warped and twisted corridors of space-time, back across that smooth, silent threshold of the event horizon. We return to the familiar universe, to the quiet of deep space, resuming our place as the silent, distant observer. Our theoretical journey is over. The star is gone. Its core is crushed. The supernova has scattered its ashes to the cosmic winds. And here, in its place, hangs the result of all that fire and fury. A black hole. Look at it. Or rather, look at the absence it creates. It does not shine. It does not burn. It does not reflect. It is a perfect pocket of night, blacker than the space that surrounds it. It is a hole in reality, a wound in the fabric of the cosmos, stitched together by the invisible thread of its own gravity. It is the period at the end of a long and magnificent sentence. A full stop. The star lived a life of dramatic, constant action. It was a churning, roiling furnace of creation. The black hole is the opposite. It is a monument to stillness, to patience. It does nothing. It simply is. Yet its influence is profound. It is a silent ghost whose presence warps everything around it. It does not emit light, but it is a master of the light of others. Watch the stars that lie far behind it. As their light passes near the black hole, its path is bent by the deep well of gravity. The black hole acts as a lens, a cosmic magnifying glass, distorting the view of the universe behind it. Starlight is warped into strange arcs and even multiple images, a celestial funhouse mirror. It is the ghost's fingerprint on the canvas of the cosmos. Imagine if our star had not been alone. Imagine it had a companion, another star locked in a graceful, gravitational dance. Before, they were two partners of light waltzing around a common center. Now, the dance continues, but one partner has become a shadow. The living star continues its orbit, but it now circles a void, a point of pure darkness, forever tethered to the ghost of its sibling. It pours a stream of its own gas towards the black hole, a river of light feeding the darkness, creating a swirling, superheated disk of matte accretion disk that shines with a final, desperate brilliance before it too crosses the event horizon and vanishes forever. This is the black hole's new life, not as a creator but as a collector. It is a patient scavenger, waiting for eons for matter or light to stray too close. It will grow, slowly, with every particle it consumes, its event horizon expanding slightly with each meal. But the true legacy of the star is twofold. There is this dark remnant, this puzzle of gravity and infinity. And then there is the other part of its legacy, the part that is now racing away from us in all directions. The supernova remnant, that beautiful, expanding cloud of gas and heavy elements. That cloud is the star's life-giving gift. It is the carbon that will one day form the basis of new life, the oxygen that will be breathed, the iron that will form the core of a new planet, the gold and platinum that will be forged into treasures on a world that does not yet exist, by beings who will never know the name of the star that created them. So the star's story is one of a perfect, cosmic balance. In its death, it gave the universe two things: a future and a mystery. It scattered the seeds of creation across the galaxy, and it left behind a perfect laboratory for the most extreme laws of physics. It gave a gift of matter and a gift of absence, a beginning and an end. And this silent, waiting ghost will persist. It will outlast everything. As the universe ages, as the remaining stars burn out and fade one by one, the black holes will remain. They are the great inheritors of the cosmos. They will float in the cold, dark expanse for trillions upon trillions of years, long after the last light has gone out. Even they, it is thought, are not eternal. Through a process of quantum mechanics known as Hawking radiation, they will slowly, almost imperceptibly, evaporate. Over an unimaginable timescale, a span of years so vast it makes the age of the universe seem like a fleeting instant, they will leak their mass back into the void as a faint thermal hiss. A slow, cosmic sigh, lasting for an eternity, until they too are gone. But for now it is here. Perfect sphere of silence, a memory of a star, a gravitational echo in the quiet of space. It is the final state of a magnificent life, a transformation from the brightest of lights to the deepest of shadows. And in its silent, patient waiting, there is a kind of peace, the ultimate peace of gravity having finally and completely won. Our cosmic voyage is now complete. We have journeyed from the brilliant surface of a living star to the theoretical heart of a singularity, and have returned to the quiet of space. We have witnessed the awesome balance of creation and destruction, the violent birth of elements, and the serene, patient darkness that follows. Let these vast, wondrous thoughts now dissolve. Like ripples on a still pond, let them spread out and soften, leaving only a sense of peace and connection to the grand, silent universe. The story of the star is over, just as your day is coming to a close. There is nothing left to do now but rest. Feel the gentle pull of sleep, a quiet gravity of its own, drawing you down into a soft and peaceful darkness. Let the journey we have taken tonight carry you into the gentle tide of your dreams. Rest deeply. Sleep well. Good night.